We've been working the last couple days on figuring out where asymptotes are located and figuring out where points of discontinuity are located. Okay? So let's see if we can remember how to find all those things and then put them all together kind of like we did yesterday, but also worry about domain and range and the actual graph and table as well. Ready? Okay. So first of all, do you remember how to find any of these things up here? Which one? Which one do you remember how to find? All of them? Okay, choose one. How do you find vertical asymptotes? Denominator. We look at the denominator, right? So we set the denominator equal to 0. Now, is that exactly what we do every single time? No, there's not enough room in this little rectangle right here to write every single thing what we've got to do. So this is just going to be our kind of like our hint for our brain. This is what we kind of start with, and then we have to go from there. Okay? What about horizontal asymptotes or removable discontinuities? What do you think? So we look at the degrees. You okay with that? Okay. What about points of discontinuity? Factor. And then look for factors that live both in the numerator and denominator. So look for common factors, similar factors, common. Look at that. I wrote outside of the box. I did. No, it's okay. It really is. Okay. Can you draw the asymptotes with dotted lines? Why do we draw them with dotted lines? Because they're not real, right? They're not really there. We draw dotted lines so we can see where nothing goes, but we don't draw solid lines because nothing goes there. They're asymptotes. Okay. Make a table of important values. I know you can make a table of values. Can you make a table of important values? Well, how about if we talk about that when we go? Yeah, places where there might be a change. For sure, we probably want our asymptotes on the table. Things like that. Yeah. 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 We can visualize what's going on. That's exactly right. Can you plot points and sketch the graph? Can you identify the domain and range? Hopefully, right? Okay. So there's 5 problems on this worksheet. 1, 2, 3, 4, 5. You're going to do 4 of them for homework, and I'm going to do 1 of them with you. Which one? I can do all of them. So don't say which one you think is hard, because I don't think they're hard. 5? Okay. So we're doing number 5. Where do you want to start? Maybe that's a good idea. Horizontal asymptotes? Because we can see it, right? Okay, so what do we do for horizontal asymptotes? Degrees. This one is 2, this one is 3. So which one is greater? Denominator. What happens if the denominator, yes it is. When the degree of the denominator is greater, there's a horizontal asymptote at y equals 0. I'm just going to go ahead and put that on the graph. I mean, we could wait till later if you want. That's fine. But since I already did it, I can't really wait till later anymore. Okay. Now what? Now we should factor, right? Because that'll help us with our vertical asymptotes and our points of discontinuity. Okay? All right, so how should we factor this? One of those is right. I need to know which one it is. X plus 3, x minus 2. Okay, I'm all right with that. Now what? Okay. Well, should we factor out an x first? Yes, for sure. Okay. So if we factor out an x first, what do we get? Correct. So now what? Oh, okay. So the fact that I have an x minus 2 in the numerator and the denominator, that means that's where my point of discontinuity is. That's true, but we're going to go another step today. Okay? It wants the exact point of discontinuity. We know the x is 2. You just told me that. How are we going to figure out the y? We can absolutely plug it in. The problem is if I plug it into this, I'm going to get undefined because it's a point of discontinuity, right? But if you'll think back to the worksheet that we did where we talked about points of discontinuity, you remember how we had, let me grab it real quick so I can remind you by actually showing you. Remember how we talked about this first problem right here yesterday? And we talked about how this x equals 0 was a point of discontinuity because it's undefined for y2 but not for y1. What if I plugged it into y1? Wouldn't that give me the y value? So if I'm looking at this problem right here, what if I just ignored the x minus 2's? Because I know that's going to give me undefined. And what if I put it in just that? Would that work? Wouldn't it? It did for this problem, didn't it? The one that we did yesterday? It gave me a y value for 0 when I plugged it into this one because I proved that these two were equivalent. These just had one more factor, right? Okay, so if I plug a 2 in, I get 5 over 14. Done. That's my point of discontinuity. It's not a half. It's a little bit less than a half, right? Okay. What else can I know now? What else can I know? The vertical asymptotes. How do I find the vertical asymptotes? Set what to 0? The whole denominator? Not the point of discontinuity, but everything else, right? So do you think we ought to find the vertical asymptotes before we've determined whether there's a point of discontinuity? After, right? I didn't mean to draw this. I'm sorry. It's just a... So tell me about vertical asymptotes. Set it to 0. Okay, what do I get? It's already factored, right? So tell me what I get. If I set each one of the factors equal to 0, x equals -5. Yeah, for that. What about this? Isn't that a factor as well? Don't I have to set that equal to 0? What do I get? X equals 0. For sure. So I've got my horizontal asymptote graphed. Here's one of my verticals right there at -5. And then here's the other one at 0. Okay with that? Okay. We can either do the domain and range and then the table and then the graph, or we can do table and the graph and then domain and range, table, graph, and then domain and range. Okay. A lot of you guys are visual people like I am. That's okay. All right. Calculator. Put in the equation x squared plus x minus 6 over x cubed plus 3x squared minus 10x. Is that what we expected? I have 3 sections, don't I, on my graph already because of my asymptotes? 1, 2, 3. I have 3 sections on my graph. Is that okay? Maybe we didn't expect exactly this shape, but we did for sure expect 3 sections this way and 2 sections this way, right? Okay, so now, well, let's talk about that in a second. Let's go Control T. Now, something I did ask when we very first started this, if you could make a table of important values. What values do we want to make sure we have on this table? So our asymptotes and our points of discontinuity, right? And then we probably want a point on either side of those too, don't we? So maybe -6, -5, -4 to take care of that one. If I have -4, do I have to have every single point in between that and -1? I don't, right? Okay, so -1, 0, and 1. That'll take care of that one. And then maybe I just, oh, well, I already have 1, so that's good. So I need 2 and 3, maybe? Will that work? Does everybody understand why I chose these particular x values? Are these the only correct particular x values we could choose? No. We want to choose our important ones, which are around our asymptotes or points of discontinuity, our x values. Okay? So that's why I went 1 on either side of each one of those numbers. This one just happened to overlap, and that was nice. Okay? So now, go to our table. I could plug these in, right? We could plug them in ourselves. We're smart enough. Most of us. Okay, that's fine. But we're just going to use our table for time-wise, excuse me, our calculator time-wise. Undefined, 0.25, -0.5, 0 is undefined, 1 is 0.6 repeating, 2 is undefined, and 0.25. Notice please how the x-axis is scaled. So when you're graphing, just be careful of that, please. I don't either. It wasn't my choice. Sorry. -0.5, so maybe right there. No, that's undefined. -4 is 0.25, so maybe right there. -1 is -0.5. -1's right here, so -0.5. 0 is undefined. 1 is 0.6, undefined. And 3 is 0.5. Excuse me, 0.25. Maybe right there. That's not anything like this, is it? Well, it is, right? Does this give me a clear picture of what my graph looks like? No, I need a heck of a lot more points, wouldn't I? Okay. Now, we have the convenience of having the graphing calculator, so we do know what it looks like. So we can go and draw that in. But what I want you to be really careful of, is the last section. Because I can't just go, can I? Because I know right here, I have a hole. I don't want to graph that hole. The point of discontinuity. I don't want to just draw right through it. I need to have it represented there. Okay? Now let's talk about our domain. All reals? Okay, so we could say it that way. We could say it in inequality notation, right? All reals, x is not equal to what? 0, -5, and 2, right? But I want to put -5, 0, and 2 because I might as well have them in order least to greatest. It's not wrong if they're the other way, just kind of little righter. Okay? What about interval notation? -5, and then -5 to 0, and then 0 to 2, and then 2 to infinity. It's a lot. Was it hard? No. We just like to whine and complain because it's a lot, but it's still not hard. We good with that? What about range? What are the y values allowed to be or not allowed to be? Everything not 0. All reals, y is not equal to 0. You're correct. We are talking about range, so it is y not equal to 0. So, well, yeah, we really need to talk about that too, don't we? Well, here's the thing. Is y allowed to be 5 over 14? What about right here? It's just that one tiny dot. It's allowed to be 5 over 14 right here. So it's still part of the range, isn't it? Okay. It just can't be it right there. So negative to positive? No, negative to 0. And 0 to positive. We don't really put that on there at all, the 5 over 14, because that's the only place it can't be. It can still be right there. All right? Now, the last thing we need to talk about, when we talked about asymptotes in the very, very beginning, we talked about the fact that things will get closer and closer and closer to them, but never touch them, right? They'll approach, but never touch. So some people have real big trouble with this one. Because I have an asymptote right here, and it's crossing. Well, here's the deal. There is an asymptote right here, and you can tell there is because of the behavior of the graph right here, and because of the behavior of the graph right here. Sometimes when it's in the middle like this, it's going to cross a horizontal asymptote. It might. Okay? It's not crossing here, and it's not crossing here. The ends are not going to cross. Sometimes in the middle, it'll cross a horizontal. It's not going to cross a vertical that I know of. In our Algebra 2 settings, it's not going to cross a vertical. Okay? There are other kinds of asymptotes, slant asymptotes. Sometimes I think they're called diagonal asymptotes, but mostly slant asymptotes. We don't talk about those in Algebra 2. We really focus on vertical and horizontal asymptotes. Okay? Sometimes slant asymptotes can be crossed as well. In the middle of something, not toward the ends. Okay? Does that make sense? All right. Do you have any questions about this particular problem? Yes, sir. Can we talk about that the week after next? Yeah. Yeah. It's in the plan. No, there's absolutely word problems that deal with this stuff, for sure. There are real life examples of this, absolutely. Okay? So yeah, but we'll get to that later, not today. Today we're worrying about the graphing of it. Okay? Do you think that you'll be okay on the rest of these problems? Look over them real quick and make sure you don't have any questions on the rest of them. I don't. Okay, that's a good idea. If you do have any questions, you can ask.